Hello everyone, we are Group 10, I'm Yuning Hongrono. Next. In this project, we stated that there are alternative hypotheses between using BMI and skin fold to measure body fat percentage. So we set the research question as a difference in calculating fat percentage with a BMI and skin fold measurement, and use three methods, including correlation, simple linear regression, and multiple regression to analyze the sample data. Next. In this study, we selected 177 sample data. The target is young people aged 11 to 19, including 100 0 and X males and 69 females. The data we got include age, gender, height, weight, waist circumference, arm circumference, body volume, and skin fold measurement of each part of body. Next. Body mass index is a person weight in a kilogram divided by the square of the height in the meters. BMI is an inexpensive and easy screening method for weight category. Next. A skin fold is a measure of subcutaneous body fat and skin obtained from several sites on the body using body fat calipers in order to determine body composition. Then I would like to pass the time to my groupmate.
Okay, we will use the Pearson correlation to find out whether there is an association between BMI and the percentage of fat. Next page, please. So what is the Pearson correlation? It is used for analyzing the linear correlation between two sets of data. The results and outcome mostly are between 1 and -1. The left-hand side graph showed the strength of the association. Next page, please. So before processing to the Pearson correlation, the scatter plot is used to find out the extra relationship. We put BMI as x-axis, percentage fat ADP as a y-axis. After use the IBM SPSS version 27, the graph shows that there are linear relationship between BMI and percentage fat ADP. After that, we know they are linearity and we can process to the Pearson correlation accordingly. Next page, please. So according to the IBM SPSS, the Pearson correlation between BMI and percentage fat ADP is 0.619, so it's quite strong. The level of significance to tails between BMI and percentage fat ADP is smaller than 0.001. So our sample size is 177, but the percentage fat has missed one statistic due to some certain issues. So I pass to another groupmate.
Then we use the simple linear regression to find the regression model between BMI and percentage fat in order to predict percentage fat with BMI. In SPSS, we put percentage fat as the dependent variable and BMI as the independent variable. From the result, we can see that there are a moderate positive correlation between two. The Durbin-Watson test that tell us the independency of residues is 0.939. From the coefficient table, we can see that p-value is smaller than 0.001, which indicates that the model is significant. Then we can interpret the model with the equation below using a standardized B of constants as M and that of BMI as C, which allows us to predict the percentage of body fat with BMI data.
And now we are going to talk about the multiple regression of using skin fold to predict the percentage of fat. Next, please. The multiple regression for skin fold measurement, each of the position were measured twice, which is the tricep, bicep, subscap, superior thigh, and the cleft. These values were averaged and news column were formed. A level of significance was 0.05 in this project. A standard multiple regression was performed between the percentage fat ADP as the dependent variable and tricep, bicep, subscap, superior, thigh, and cleft. These are the skin fold measurement as independent variables. Analysis was performed using IBM SPSS. The resulting table displays is on the left, and you can on the right you can see the unstandardized regression coefficient as the p-value and intercept the standardized regression coefficient as beta R2 and adjust R2. The adjust R2 value of 0.825 indicates that more than 80% of the variability in percent fat ADP was predicted by the 6 skin fold measurements. Regression analysis revealed that the model significantly predicts percent fat ADP, and the F value is equal to 138 and 138.168, and the p-value is less than 0.001. Next. For each of individual relationship between the independent variables and percentage fat ADP, we can find that triceps skin fold measurement, the t-value is 2.950, and p-value is equal to 0.004, and subscat is the t-value of subscat is minus 2.114, and p-value is 0.036, and the superior skin fold measurement t-value is 5.125, and the p-value is less than 0.001, and the cleft skin fold measurement t-value is 4.727, and p-value is less than 0.001. Each of the significantly predict percentage fat ADP. However, there was two predictors that were not significant, which is bicep and thigh. The bicep t-value is 1.937, and p-value is 0.054, and thigh is the t-value of thigh is 1.263, and p-value is 0.208. Based on the standardized coefficient, the superior, cleft, and the tricep are the three most important predictor of percentage fat ADP.
Then we run the regression again to find the best fit line for the three variants. The Durbin-Watson test is 1.893, and the F value is 264.31. P value is smaller than 0.001, which indicates that this is a significant model to predict percentage fat with these three skin fold measurements. And below we have the equation that allows us to predict percentage fat with the three skin folds measurements.
So for the discussion of Pearson correlation, first we should identify that the extra relationship between two factors. The scatter plot diagram helps to show clearly in the positive or negative relationship. After the analysis, the graph has obviously showed us positive direction. So we can find out the linear relationship in between. Second, we proceed to the Pearson correlation. The data of the Pearson correlation is R equals to 0.619. Which means there are large positive strings in between based on the string of coefficients. Furthermore, as the level of significance is smaller than 0.001, which is smaller than 0.05, so the result is significantly differences. However, the correlation only tells and shows that the relationship in between. We still cannot know any more about the cause and effect relationships. Moreover, due to some special issue, one of the data has lost and may increase the uncertainty.
By doing simple linear regression, we can find the equation in our results that indicates there are differences in predicting body fat percentage with BMI and triceps, superior, and calf skin fold measurements. When we use BMI to predict body fat percentage, it is a linear model. But when we predict body fat percentage with the three skin fold measurements, it is a 3D model. So there is a difference in these two methods. Second, predicting body fat percentage with skin fold measurements is more valid compared to predicting body fat percentage with BMI. The Durbin-Watson test results are 0.939 and 1.893, comparing percentage fat with BMI and percentage fat with skin fold measurements. From the table, we can see that when we use BMI to predict percentage fat, DW value is smaller than DL. So it indicates that the data is not independent, which will affect the validity. From the table, we can see that if the Durbin-Watson value is smaller than DL, that indicates the data is not independent, which affects the validity. But if DW is larger than DU, that indicates that the data is independent. Therefore, predicting body fat percentage with skin fold measurements is more valid.
Multiple regression. Our result revealed that skin fold measurement is a reasonable estimate of present body fat in Chinese teenager aged between 11 and 18. The high correlation between percent fat and skin fold, separate calf and tricep, so that these three skin fold measurements are a reasonable variable predicting body composition in teenager, and they are critically important predictor of present fat. However, the other two predictors, which are bicep and thigh, are found insignificant. Therefore, the skin fold methods could be treated as an alternative to laboratory methods in a clinical setting where laboratory test equipment methods are not available for separate calf and tricep, but not for bicep nor thigh. Next.
So in conclusion, we accept our hypothesis and agree that there is a difference between using BMI and skin fold measurements to estimate body fat percentage. In our analysis, we used Pearson correlation to find that there are positive correlation between BMI and percentage fat ADP. Then we used simple linear regression to find the equation to predict percentage fat with BMI. Lastly, we used multiple regression to find which body parts measurements can predict percentage fat and the equation to predict percentage fat using triceps, superior, and calf skin fold measurements. Here is the reference list for our presentation. This is the end of our presentation. Thank you.